My barbecue awareness survey. And let's say I hand my survey out and I give my survey to 15 people. Okay? Now, my surveys come back, and on this particular survey, I have a Likert scale and I have 4 questions. And these 4 questions reflect the construct, are you barbecue aware? Okay? And I come back and the mean score on this survey is 3.5. Now, I can only survey 15 people. This is inferential statistics. So, I get my 15 surveys back, and I have to get the same numbers. So, I get a sample size of 15. Now, in this case, the mean of all my surveys, let's say that it's 4.2. And let's say that the standard deviation of the mean of all the surveys is 1. So we always need this information for the sample. Okay? All right, now, how do we conduct the test? Well, let's say that we believe that in the general population, the mean value on the barbecue awareness instrument is 2.5. Okay? Now, this could be any construct. This could be a measurement of IQ in the population. This could be a measurement of social awareness. Any type of construct you want to measure, as long as your instrument is valid and reliable, is not the issue. It's the statistics that it matters here. So, our alternative hypothesis is that the mean score, if everybody in the population took the instrument, was not 2.5. So the test then is conducted the exact same way. All right, so we take the one sample t-test calculator, what we have right here, and we put in some new numbers. And we're going to change our hypothesized value to 2.5. We're going to change our sample mean to 4.2. We're going to change our standard deviation to 1. And we're going to leave our sample size 15. Then we're going to hit calculate. And as you can see again, we're going to get a p-value of 0.0001. So what could you say as an educational researcher? You could say that it's commonly believed, that's the hypothesized value, that the mean number on the barbecue awareness scale in the population is 3.5. Now, this could be any instrument. This could be dealing with special education. This could be dealing with the school environment. This could be dealing with attitudes. But you still have to have some type of hypothesized number as to what it would be in the population. And then you take your sample, you distribute your sample instruments, and you get your sample data. Now, since the p is 0.001, clearly less than an alpha of 0.05, you could, as a researcher, reject the null hypothesis that the mean value of barbecue awareness in the population is 2.5 in favor of the alternative, which is that it is not 2.5. That would be research, so you're discovering something. That's how the process works. Now, same thing happens. Let's say we change the standard deviation. Let's change it to 3. And let's not change the mean. So the standard deviation of the 15 samples is now 3. So I go back and I change that to 3. And I hit calculate. And what happens? Well, I get a new p-value. 0.4 0.0456. So we didn't change the mean of the sample, but the sample's variability, the standard deviation, is a lot wider. That changes the mathematics of how we do the test. So we now have a p-value of 0.0456, which is still less than 0.05, so we can still reject the null hypothesis. However, let's change the standard deviation just a little more. Let's change it to 3.5. And we have now a p-value of 0.08. 0.0809. And what that means, since that is larger than the alpha, we cannot reject the null hypothesis that the mean value in the population is 2.5. So it's important to go into the calculator and experiment. That's why we build the course on the calculators. There's a lot of learning occurs which can be had by